Okay, in this example I'm going to show you how to do a linear programming transportation model. Transportation model involves getting the right number of units to make from a certain plant and to ship to a certain retail store. And you want to do that in such a way that minimizes the shipping costs. So here you have all the shipping costs. This is from the original problem. You've got 2 plants and 2 retail stores, and these are all the shipping costs in blue here. Plant 1 has a capacity of 300,000 units, while Plant 2 has a capacity of 500,000 units. Retail store 1 has a demand of 350,000 units, and retail store 2 has a demand of 400,000 units. How many units should be shipped from each plant to each retail store to minimize shipping costs, and what is the total shipping cost of the optimal solution? So that's the problem that you have to solve. Now anything in blue here is considered an input to the model. Anything in orange is considered the output of the model or the solution to the model, and anything in green is information that you have to provide. Now this problem has already been solved, but I had to put formulas in here in all of the green spots, and then I had to use solver. So you have to check to make sure that you have solver in your Excel environment by going to data and then looking to the far right here. If it doesn't say solver here, then that means you need to go to file. Then you need to go to the very bottom to options. Then what you need to do is you need to go to add-ins and then look in the inactive application add-ins down here for solver. I already have mine added, so it appears in the active application add-ins area, but yours will be in here somewhere. So click on solver add-in and then press the go button, and that should put it up in the active application add-ins. Press OK, and then go again to data and check to make sure that you have solver up here because you need it. Okay, then what I have to do is I have to use solver in order to solve the problem. So this is what I'm going to do now. I'm going to give you an unsolved problem, and then we're going to put all of the formulas in it and then use solver in order to get the right answer. So you have to lay out your problem first of all with all of your shipping costs at the top, and then what you have to do is you have to lay out the solution area right here, and you need to just come up with a formula here. The sum of all this is equal to the sum of all this, and that must be less than or equal to 300,000, and the sum of everything that's made in plant 2 needs to be less than or equal to 500,000, and I got that from this first sentence right here in the problem statement. Then we need to go equal sum, and we need to highlight all this, and we need to go equal sum, and we need to highlight everything that was shipped into retail store 2. Okay, so that gives us the total demand that we've satisfied. Okay, the last thing you have to do is calculate the value of the objective function, which is the minimum shipping cost. And to do that, you use the sum product function, and you highlight all this, comma, and highlight the orange area. Enter. Now that's going to give you 0 as well because we haven't solved the problem yet. So now what we need to do is solve the problem by going to data and going to solver. Now I've previously worked on this problem earlier, so I'm going to take out all of these items so that we have the fun of putting them back in again. Okay, so when you start off, I think it looks like this, your blank screen. The first thing you have to do is you have to tell it what the objective is, which is this right here, by changing these cells in orange, subject to these constraints. So click the add button and say this must be less than or equal to this. Click on add. This, the total amount produced in plant 2, must be less than or equal to its capacity, 500,000. Add. The total amount shipped into retail store 1 must be, and you got to change this to greater than or equal to 350,000. Add. And this value here in cell E15 must be greater than or equal to 400,000. Click on add, and then click on cancel. that brings up the linear programming model. You've entered the objective function, the cells, which are your decision variables, and then all of these constraints. Make sure this is sent to simplex LP because we are assuming a linear relationship between all of the different variables in this situation. If there was nonlinear, we'd use GRG nonlinear, but everything is linear in this course. So we click on solve, and it said that it found a solution, and we just click on OK, and you can see that the optimal solution is 300,000 units shipped from plant 1 to retail store 1, 0 units shipped from plant 1 to retail store 2, which makes sense because that's really expensive. It's at $3 a unit. Plant 2, you sell 50,000, you make 50,000 units and ship them to retail store 1, and from plant 2 to retail store 2 you send off 400,000 units. So that satisfies all of the constraints and produces a total minimal shipping cost of $1.325 million. And that's how you use Solver in order to solve a linear programming transportation minimization problem. Thanks.